geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A particle of mass m is projected with velocity v at an angle theta with the horizontal. At its highest point, it explodes into two pieces of equal mass. One of the piece continue to move on the original trajectory, then the velocity of the second piece is. It is like this. Let us take the horizontal surface that I am marking as ground. With respect to that ground, a particle of mass m is projecting with a velocity v at an angle theta. Then it is maintaining the projectile motion. The path followed by the particle is called trajectory. Look at the highest point. This is the highest point. At that highest point, that particle is exploding into two equal masses. M is exploding into m by 2 plus m by 2, but one piece is maintaining the same trajectory with a velocity v cos theta. Same trajectory means horizontal component of velocity remains same, because since the particle is projecting with a velocity v at an angle theta, it is developing two component of velocities v cos theta and this is the v sin theta. Horizontal component of velocity v cos theta remains same. That means m by 2 mass is maintaining the right same horizontal component of velocity. Another mass, it is not given in which direction that other piece is moving. Other mass is m by 2, maintaining the velocity, let it be v dash. Then what is the velocity of that other piece? That's what he is asking. Okay, very easy question. Now let us take the law of conservation of linear momentum. According to according to law of conservation of linear momentum, listen carefully. Conservation of linear momentum, linear momentum. Initial momentum is what? M into v cos theta. Mass of the particle is m into horizontal component of velocity is equal to m by 2 into v cos theta. This is the momentum maintained by the one particle which is following the trajectory. Other momentum is m by 2 into v dash. V dash. Okay, then v dash is the second piece velocity. That second piece velocity v dash, otherwise 1 minute. Let me write it clearly. It can be also written as mv cos theta minus mv cos theta by 2 is equal to m by 2 into v dash. M cos theta, mv cos theta minus mv cos theta by 2 equal to mv cos theta by 2 is equal to m by 2 into v dash. Now here m is cancelling. Of course 2 also cancelling. V dash equal to v cos theta. That means that is maintaining the same horizontal component of velocity. Look at the options. Option B is absolutely correct. Understood clearly? It is 5-star problem. Means most important problem. This kind of problem can be repeated. Okay. Similarly, let us take the another important problem asking like this. A body of weight 2 kg is suspended as shown in figure. To get the weight suspended, the weight is given 2 kg weight in the figure. The tension T1 on the horizontal string. What is the T1 value? That is the question. Very easy question. By applying the sine rule, it can be decided. Now, since opposite angles are equal, if I project a horizontal line like this is also 30 degrees. If this is 30 degrees, this entire angle is, this is 90, this part is 90 plus 30, 120 degrees. Then project the vertical line, it is equal to 60 degrees, simple mathematics. Then this whole angle 60 plus 90, 150 degrees, and this is the 90 degrees. With that, let us redraw the diagram. Here, one tension, right? Let the tension is T2. Let the tension is T2, and this tension is T1, and weight is acting vertically downwards. That is 2 kg weight. Okay. You know this is the, let us change the color. This is 90 degrees, and this is 150 degrees. This is called free body diagram. This is equal to 120 degrees. Then there is a sine rule. The sine rule is this T1 by sine of the opposite angle. Let me write it clearly. This T1 by sine of the opposite angle means 120. T1 by sine 120 is equal to T2 by sine 90 is equal to this 2 kilogram weight, 2 kg weight by sine 150. Sine 150. Otherwise, let us take another slide. So we have decided this is T2 and this is 120, this is 150 and this is 90. The sine rule is also called Lami's theorem. Says that the T1 by, listen carefully, T1 by sine of the opposite angle, that is 120, is equal to T2 by sine of the opposite angle, sine 90, is equal to weight, that is 2 kg weight, divided by sine of the opposite angle, sine 150 degrees. Since you are asked to decide the T1 value, let us take the first relation and the last relation. T1 by sine 120 degrees is equal to 2 by sine 150 degrees. So T1 equal to 2 sine 120 dividing by sine 150. You simplify it. It is equal to 2 into sine 120. I can write as sine 90 plus 30 degrees divided by sine 90 plus 60. It is equal to 2 into sine 90 plus 30 cos 30 divided by cos 60. It is equal to 2 into cos 30 root 3 by 2, cos 61 by 2. This 2 cancel. It is 2 root 3. 2 root 3. That is the T1. Similarly, by equating the second one and third one, we can also decide the T2 if it is asking in the examination. Okay, anyhow, T1 equal to 2 root 3. T1 equal to 2 root 3. Option C is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. It is asking like this. A ball of mass 0.2 kg is thrown vertically upward by applying a force by hand. So a ball is thrown by a hand. If the hand moves 0.2 meters, this is the position of the particle. This is the position of the particle. Right? This particle is thrown upwards. Thrown upwards. So here hand is moving 0.2 meters while applying a force. That means by the time the hand force is acting on the ball, along with the ball, hand is moving 0.2 meters and the ball goes up to, right, 2 meters. This is the ball distance moving. That is the distance traveled by the ball. but hand is moving only 0.2 meters. That means force is transmitted to ball by the time the hand is in touch with the ball. Therefore, the force is applied on the ball for a distance of 0.2 meters only. Okay. Then up to 2 meters height. Then find the magnitude of the force. You're asked to decide magnitude of the force. Very simple. You know, the energy possessed by the particle at P is the potential energy only. That is mgh. That is the potential energy at state P must be equal to hand force. That is the kind of energy. Hand force multiplied by distance moved by the hand. Hand movement. Hand movement. Let me write it clearly. Hand movement. So m equal to how much? 0.2 kilograms. G 10 into total height. This is the total height traveled by the ball. 2.2 meters. 2.2, it is equal to hand force F into the distance moved by the hand, that is 0.2 meters. This 0.2 cancel. 10 into 2.2, 22. The force acting, therefore the force is acting on the ball is 22 newtons. That is the answer. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. The coefficient of friction between the rubber tires and the roadway is 0.25. Coefficient of friction mu equal to 0.25. The maximum speed with which a car can be driven round a curve of radius of curvature are equal to 20 meters without skidding. Look at the G value. Here G not given 10 equal to 9.8 meter per second square. So at what maximum speed you can maintain in the car without skidding the car. Okay. The condition for that is mv square by r must be equal to mu mg. Okay. Here this m is cancelled. Then v square equal to mu r g. It is equal to mu 0.25 into r value 20 into 9.8. Here 0.25 I can write 1 by 4 into 20 into 9.8 is equal to 5 into 9.8. 4 5 times. 5 into 9.8 is 49. So you got v square equal to 49. Then what is the v value? Root 49 equal to 7 meter per second. That is the maximum speed that we can maintain in the car for avoiding the skidding while you are taking turn in a curved path. Okay. Look at the option B. Option B is absolutely correct. Okay. Similarly, look at the another important problem. It is asking like this. A body of mass 2 kg is placed on a horizontal surface. Mass of the body given 2 kilograms placed on the horizontal surface having kinetic friction 0.4. Coefficient of kinetic friction mu k equal to 0.4 and coefficient of static friction is equal to 0.5. If force applied on the body is 2.5 newtons, force applied equal to 2.5 newtons, then frictional force acting on the body will be, as you know, frictional force or limiting friction, I can say. Limiting friction equal to mu s into m into g. Mu s is 0.5, m is 2 into g given 10. For the previous problem, it is 9.8. Here it is zero point 0.5. Zero point 0.5 into 2, otherwise 10 into zero point 0.5, 5 into 2. That is equal to 10 newtons. That is the limiting friction. But the given force is less than the limiting friction. Therefore, the frictional force acting on the body is what, 2.5 newtons only. The same as applied force. Once again, since the applied force is less than limiting frictional force, therefore the frictional force acting on the body equal to given force only. Option D is absolutely correct. Okay. Similarly, let us take the another important problem. Look at this problem. It is asking like this: a body of mass m moving in a straight line with momentum p, initial momentum equal to p, starting from rest, means at t equal to 0. A force F equal to, given force F equal to A into T, acts on the same direction on the moving particle during the time interval of T, so that its momentum changes from P to 2P. Final momentum equal to 2P. Then what is the value of T? What is the value of T? Okay. For that, as you know, according to Newton's second law, force F equal to, right, dP by dt. From this, dP equal to F dt. But look at the F value which is given. F value is given as uh, 80. F value is given as 80. It is 80. So dP is equal to F equal to 80 into dt. Then upon integration, integral dP from lower limit p, upper limit 2p, equal to a constant, integral t dt 0 to t. Okay. Then it can be written as, so let us write it. I am applying the limits. 2p minus p is equal to a into t square by 2. Directly I am writing. Then p equal to a by 2 into t square. From this, t square equal to 2p by a, or the time t equal to root over 2p by a. That is the answer. 2p by a. Look at the option. Option A itself is absolutely correct. Understood clearly? Yes. Similarly, let's take the another important problem. Okay. Look at the screen. It is asking like this: a maximum of 3 newtons force can be applied on a block down the incline that would still not move the block which is placed on a rough inclined plane as shown in the figure. Look at the downward force acts on the block parallel to the plane. It is given that though 3 newtons downward force is acting, the block is not moving. It means frictional force will be more than this applied force in the downward direction. Okay. Similarly, the maximum external force of the inclined plane that does not move the block is 12 newtons. Similarly, look at the upward force applied on the block parallel to the plane, 12 newtons. Then the coefficient of static friction between the block and the plane. You're asked to decide what is the coefficient of static friction between the block and plane. It is given G equal to 10 meter per second square. Okay. For that, it is better to mark the diagram separately for downward force and upward force, or downward motion and upward motion. First, let us take the downward motion. For downward motion, downward force. Look at the force. look at the force. Right, force is acting parallel to the plane downward direction. This is the normal reaction direction. Look at the self weight. Self weight is acting vertically downwards with a magnitude mg, and this is the 30 degrees. Then it is developing two component of weights. This is the mg cos 30 degrees, and this is the mg sin 30 degrees. Then the block tends to move in this particular direction. This is the direction of motion. Then frictional force is acting in this particular direction. Okay. Then let us balance the two forces. Here the frictional force must be equal to 3 newtons plus mg sin 30. Okay. Similarly, let us take the uh, upward force. Upward force. For upward force, look at the normal reaction. This is the normal reaction. Okay. So this is the self weight which is acting vertically downwards. This is the angle 30 degrees. Then developing mg cos 30 degrees, and this is mg sin 30 degrees. Here force is applied in this direction. Therefore frictional force is acting in this direction. Now let us apply the uh, force balance equation. mg sin 30 plus f. Right? These two are acting in the down direction, must be equal to 12, that is in the up direction. Okay. But already we have written the f value, f equal to 3 plus mg sin 30. So mg sin 30 plus 3 plus mg sin 30 equal to 12. Equal to 12. So this is the mg sin 30 plus mg sin 30. 2 mg sin 30 plus 3 equal to 12. 2 mg sin 30 is equal to 12 minus 3 equal to 9, or mg sin 30 equal to 9 by 2. Okay. Now let us write the let us take the same formula. Here mg sin 30, mg sin 30 plus f equal to 12. F equal to what? F equal to mu n, mu into, look at the n, this n must be equal to mg cos theta. Mg cos theta, let me write it clearly. It is mu mg, f equal to mu into n equal to mg cos 30 degrees. So mg sin 30, this mg sin 30 already got it, 9 by 2 plus f equal to what? Mu mg cos 30 is equal to 12. From this, mu mg cos 30 equal to 12 minus 9 by 2. So it is 24 minus 9 by 2 equal to 15 by 2. That is the mu mg cos 30. Let's take another slide. Here you got mu mg cos 30 equal to 15 by 2, you got it. And mg sin 30 equal to 9 by 2 mg sin 30 equal to 9 by 2. Let this is the equation number 1. Equation number 2. 1 dividing by 2, it gives mg sin 30 divided by mu mg cos 30 degrees is equal to 9 by 2. 9 by 2 into 2 by 15. It is equal to 9 by 15. 9 by 15 equal to 3 by 5. 3 by 5. So this mg part is cancelled. Mg part is cancelled. Here sin 30 by cos 30. You can write tan 30 divided by mu equal to 3 by 5. From this mu equal to 5 tan 30 degrees divided by 3. It is equal to 5 into, tan 30 degrees equal to 1 by root 3. It is equal to 3 root 3. That is the mu value. Therefore, mu equal to 5 divided by 3 root 3. That is the answer. I hope all of you clearly understood. Understood or not? I try to explain the each and every point at your understanding level. Okay. Now look at the options. 5 by 3 root 3. Look at the option. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem asking like this. The force on a body of mass 1 kg is force F is given 20 I cap plus 10 J cap. That is the force. Of course, mass is given 1 kilogram. If it starts means initial velocity u equal to 0. Then position of the body at a time t equal to, when t equal to 2 seconds, what is the position of the body? Position of the body is what? So position can be decided in terms of x coordinate and y coordinate. For that, as you know, this 20 newtons can be written as Fx. Fx equal to 20 and this is the Fy equal to 10 newtons. But according to Newton's second law, force F equal to ma. Force F equal to ma. From this, acceleration equal to force multiplied by mass. The force divided by mass. Then acceleration along the x direction equal to force along x direction divided by mass. Force along x direction is 20. Divided by mass is 10. 1. It is equal to acceleration along x direction is 20 meter per second square. The same way, acceleration along y direction equal to force along y direction divided by mass. Force along y direction is 10 divided by 1 equal to 10 meter per second square. Okay, let us take another slide. Acceleration in x direction equal to 20 meter per second square and acceleration in y direction equal to 10 meter per second square. Then the horizontal displacement x equal to ux ut, s equal to ut plus half at square. That is one of the equations of motion. So ut uxt plus half into ax into t square. Anyhow, initial velocity is given clearly. It starts from rest means, right, ux equal to uy is equal to 0. Okay. So it is equal to this ux equal to 0. Then x equal to half into ax 20. T is given 2 square. Here it is 20 by 2, 10 into 4 equal to 40 meters. Similarly, y can be decided. Y equal to uyt plus half ay t square. this uy equal to 0, uy equal to 0, y equal to half into ay 10 t 20 t 2 square. Here it is 5 into 4 equal to 20 meters. So horizontal displacement is 40 meters, vertical displacement 20 meters. 40 and 20. Look at the options. 40 and 20. Option D is absolutely correct. Are you following clearly? Yes.
Geobyte.